Okay, so black holes. We all have this image in our heads, right? These ultimate cosmic monsters, giant vacuum cleaners that swallow everything, even light. But what if that's just scratching the surface? Seriously, let's take a trip together from what we think we know right to the absolute edge of physics.
All right, let's just get right to it. The big one. What really happens if you fall into a black hole? I mean, what would you actually feel in those last moments? Well, let me tell you, the universe has a very graphic answer.
Yep, you heard that right. Spaghettification. Sounds kind of funny, doesn't it? But trust me, it is anything but. Imagine this. As you're falling in, feet first, the gravitational pull in your feet is just way, way stronger than the pull on your head. And that difference, that tidal force, it would just stretch you. It would pull you apart, thinning you out into this incredibly long, thin strand of atoms. Literally cosmic spaghetti.
But here's the crazy part. Your survival, at least for a little while, really depends on the size of the black hole you pick. If you're unlucky enough to fall towards a smaller one, a stellar mass black hole, those tidal forces are so insane that you'd be turned into spaghetti long before you even reach the event horizon, the point of no return. But if you fall into a supermassive black hole, the gravity is spread out more gently. You could actually float right across the event horizon, totally fine, completely intact. The real trouble would only start much, much later, deep inside.
Okay, so this whole spaghettification thing, this warping of space, it's not just some random chaotic event. Nope, it's all playing by a rule book written over 100 years ago by Albert Einstein. And this is where things get really weird.
See, here's the thing you got to wrap your head around. Einstein showed us that gravity isn't really a force in the way we think about it. It's actually the shape of space and time, space-time, being bent by massive objects. The classic example, right? Put a bowling ball on a trampoline and it makes a dip. Little marbles will roll towards it. A black hole is like that, but instead of a bowling ball, it's an infinitely heavy point, creating an infinitely deep well.
But what if that massive object isn't just sitting there? What if it's spinning? Because, oh yeah, they spin. A lot. And when a black hole spins, it does something absolutely wild. It doesn't just bend space-time, it actually grabs it and drags it around.
This mind-bending effect is called frame dragging. The best way to picture it is like a spinning top in a bowl of honey. It doesn't just sit there, right? It creates this little whirlpool. A rotating black hole does the same thing, but to the very fabric of reality. It twists space-time into a vortex. So if you're nearby, you're not just falling in, you're getting swirled around, caught in this cosmic drain.
And get this. This isn't just some crazy theory on a whiteboard. It's real. Scientists actually saw it happen. They were watching a star get ripped apart by a black hole, and they saw it wobble. But here's the kicker. It wasn't the star that was wobbling. It was space-time itself. The star was just along for the ride. I mean, can you believe it? Einstein predicted this a century ago. The man was just on another level.
Okay, so now that we've got the physics down, sort of, it's pretty wild, we can start to appreciate that not all black holes are the same. Not even close. The universe has a whole zoo of these things, from the quiet guy next door to absolute monsters on the run. So let's start close to home. Meet our nearest known neighbor, Gaia BH1.
So Gaia BH1 is what we call a stellar mass black hole. It's about 10 times the mass of our sun, which sounds like a lot, but in the grand scheme of things, it's pretty standard. It's actually dancing with a star that looks a lot like our own sun. And it's just 1,560 light-years away. In cosmic terms, that's practically our backyard. It's like a sleeping giant just hanging out.
Okay, so that's the quiet neighbor. Now, let's meet the complete opposite, an absolute monster. Astronomers recently found something they could barely believe, a supermassive black hole that got kicked out of its own galaxy and is now just careening through space. First, its size. We're talking 10 million times the mass of our sun.
And its speed, it's flying through space at 2.2 million miles per hour. That is so fast, it's almost 3,000 times the speed of sound. Just insane.
But here's the most incredible part. As it tears through the empty space between galaxies, it's hitting clouds of gas and triggering a wave of star formation behind it. It's leaving a trail, a tail of brand new stars that's 200,000 light-years long. To put that in perspective, that trail is twice as wide as our entire Milky Way galaxy. It's a black hole that's creating life in its wake.
Even the scientists who found it were just floored. Peter van de Kume, the lead researcher, basically said, it boggles the mind. The amount of force you'd need to punt something that huge out of its galaxy, it's almost unimaginable. They think it was probably the result of some crazy gravitational pull game between three supermassive black holes.
All right, so everything we've talked about so far is stuff we can actually, observe. But what about the stuff we can't see? What's actually going on inside, past that point of no return? This is where the physics we know just breaks, and where things get really, really speculative.
You've seen it in the movies a million times, right? The idea that a black hole could actually be a doorway, a wormhole, a shortcut across the universe? Well, believe it or not, that's not just for sci-fi. Physicists are looking at this stuff seriously.
So a wormhole is basically a tunnel through space-time. Sounds great, right? There's just one tiny problem. It would collapse instantly. The only way to keep it open, at least in theory, would be to use something called exotic matter, a bizarre substance that would have to have negative energy, basically creating anti-gravity to hold the tunnel open.
And people are actually working on the math for this. There's this cut and paste technique where you basically take the blueprints for two black holes, you mathematically snip out the impossible, infinitely dense part in the middle, and then you stitch the two openings together, and voila, you've got a stable tunnel. At least, in the equations.
But what if the other end of the tunnel isn't just another place in our universe? What if it's something else entirely, a different kind of thing?
Get ready for this. The white hole. It's the literal cosmic opposite of a black hole. If a black hole is a place you can only go in and never come out, a white hole is a place you can only come out of and never go in. It's a theoretical object that just violently spews out matter and energy. The idea is that maybe, just maybe, quantum physics stops a black hole from crushing down to an infinite point, and instead it kind of bounces and becomes a white hole.
And this actually solves a huge problem in physics. See, in the quantum world, things can't just disappear. Information can't be destroyed. So that singularity at the center of a black hole, where time and space just end, that might not be allowed. So turning into a white hole could be the universe's neat little trick to make sure nothing is ever truly lost.
So that leads us with one last absolutely mind-blowing thought. We've always thought of black holes as the end of the line, the ultimate dead end for matter, for light, for time itself. But what if they're not endings at all? What if they're actually transformations? If a black hole can turn into a white hole, a thing that spews out matter and energy, well, doesn't that sound a lot like a beginning? Could a white hole have been the spark for our Big Bang? Are we living in the aftermath of a black hole from another universe? The answers for now are still waiting for us, just on the other side of that horizon.